So here this car cooler and warmer. It's from Orion. So it cools and it warms. It looks like this. It's a blue box. It has a handle. So it's cooling and heating. It can be powered either from alternating current from at home at 220 volts or from direct current 12 volts from a car. Eco-friendly, CFC free, so it does not have freon gas in it. It's without a compressor. It has a thermoelectric device, a Peltier element. Okay, and the capacity is 24 liters. That's the inside capacity. The model is EC-987C. That's the side. So it's a car cooler and warmer, 24 liters, cooling performance 10 to 15 degrees below the ambient temperatures, heating performance to 50 degrees or 60 degrees. It has a thermostat, so it has a thermoelectric solid state heat pump. That's a Peltier element. One side heats up, the other side cools down. The insulation material is a styrofoam, 12 volts or 220 volts. It has a built-in adapter. On DC mode consumes 40 watts or 48 watts. AC mode it consumes a little bit more, 48 and 52. It has an eco mode which consumes only 8 watts. 3.5 kilograms, with the box probably 4.2. 39 centimeters, 23 centimeters and 42 centimeters. Nothing else in the box. It has a handle. It looks like this. Here's the cable. It's just pushed down. Cable length is around 1.5 meters. That's a 220 volt plug. And here's a 12 volt plug also. It must have a fuse in it. Yes, there's a fuse. 250 volts, F 6.3, L 250. It feels pretty sturdy. The length is also identical, around 1.5 meters. It has an opening here, so you can put the wires there and close it. Handle goes onto the wires, so put it onto the other side. Okay, here it has cold and hot and off. So that's cold, that's off, that's hot. 3 positions. Okay, it has an LED, eco mode, off and maximum. Eco, off and maximum. So you can open it from this part. There's no door here. You can put your finger there. It looks like this. Okay, and if notice here at the side, if you move it, let's say there, it's locked, and there's locked also, it cannot exit. And here there's a cut, so it can come up. So this is blocking. So when the handle is towards the switches, it's unlocked. When it's towards the cable, then it's locked. You cannot open it. This top part is pretty heavy. The electronics are here. It says A+. So the power consumption is around medium to low. 97 kilowatt hours per year. 24 liter capacity. 35 decibels noise. Instruction manual. Okay, let's power it on. Plug in this one. Let's use a power meter. It says 0.2 watts. Let's set it to cold. 1.3 watts. So it's consuming 1.3 watts on cold mode. 60 watts is set to maximum. Now it's on off, and now on eco mode. In this economic mode, the fan is still spinning, but at a very low speed, and it's consuming around 6 times less, only 10 watts of power. So if it's set to cold, then it should heat up on this side. Let's leave it a few seconds. So it's set to maximum and to cold. Power consumption went down to 54 watts instead of 60. And the air is colder on this side. There's nothing here. Probably this is a suction and that's the exhaust. By the way, this side is warm. I don't think anything here. Maybe this is the entrance, that's the exit for the warm air. So here it's warm. So off is present here and there also. So if you move it to the center, it's off. If you move that one to the center, it's also off. Higher power consumption, lower power consumption, heating on the inside or cooling down on the inside. So here's the thermometer. Let's see if it's good or not. It says 24 degrees Celsius here. Let's place it inside and wait a little bit. Ouch. Turn off the display. After just a minute, it's also 24. Here's a thermometer. Celsius is on the left side and the temperature is around 24 degrees, 20, 22, 24. So let's introduce it inside. By the way, the walls on the inside are noticeably cooler. You cannot feel the coolness of the air itself, but you can feel that the plastics on the inside are cool to the touch. 14 and 50 minutes. After around 70 minutes, let's check the temperature. And it's at around 13 degrees. 13 instead of 24. Let's put it back. So let's check it after almost half an hour. So it was around 13 degrees and now it's 11 degrees, 10 and a little bit, 11 degrees out of 24. So from 24 it came down to 11. 13 degrees Celsius in around half an hour. It's consuming 53.9 watts. Water is kinda cold. It's definitely colder than it was. And this is at only 18 degrees. So it needs some time until it cools down something. This is warm a little bit, just a little bit. By the way, this is the input, this is the output. If I block this one, then no air exits there, so don't block that area, nor that one. Here it's cold, that's the input of the cold side, that's the exit of the cold side. Here's a car battery, which is pretty discharged. It provides only 12.3 volts. By the way, when you connect this, there's a relay inside somewhere. So now it's set to cold, we have a green LED. Now it's set to warm, we have a red LED. Now the air here is getting colder. And the air here should get warmer. So in the heating mode, the heat goes inside, but outside here it's like air conditioning, you get cool air. So hot refers to the inside, on the outside it's air conditioning, it's cold. So now it's powered from the battery. Here's the 12 volt plug, and let's measure the amp consumption while it is off. This one is off. When I connect this, there's a click sound, so there is a relay, and although it's off, it's consuming 0.06 amps, that is around 60 milliamps. So nothing is on, no LED is on, but it's still consuming. If I set it to cold and now power it, it's consuming 3.3 amps. By the way, this wire is very thin. It has heat shrink on it, but it's very thin, so it's probably reducing the power consumption. This might be somewhat thicker compared to that one. So on the left side is my battery connections wire, and on the right side is the refrigerator's wire, and this is thicker compared to that one. So if I power it on from 12.38, it goes down to 12.10, 0. After, let's say, half an hour or something like that. The voltage is not too low at all, so it's not consuming too much. That old battery is still pretty usable. These are getting pretty cold. I mean, noticeably colder. After 5 minutes, the voltage dropped to 11.99. So it's consuming around 3 amps from the battery. If this wire would have been thicker, probably it would consume even more. Just out of curiosity, I removed the tip so that I can see the fuse. Here's the fuse inside, and I was curious if it's glowing red hot or not, but there is no heating up at all. This is working, but nothing is glowing, no light inside. So this wire got pretty hot, so do not use thin wires on a car battery. I want to replace it with a slightly thicker one. This has to be at least 1 millimeter in diameter. Look at the thickness difference. How thin are these? They also have insulation on them compared to these. Thin wire, thicker wire. That's a 12 volt plug. So the cable was replaced. Now it's thicker, and with a thicker cable the cooling device consumes more. It's not consuming around 3 amps, but around 4.2 amps and going down. The battery is not too powerful. When the cooler is powered from 12 volts from a battery, this echo mode is not doing anything. Off is not doing anything. Echo is not making it slow down. This turns it off, but it's not spinning slower on eco mode like it does when it's powering from 220 volts. This part is available only for 220 volts. Nothing, no change. So here's a variable transformer. It's powered from 220 volts, but it's outputting only 12.3 volts right now. And of course it's working. But let's see what's the minimum voltage. At around 9 volts it's working, at least the fan is spinning. Let's set it to 5 volts. The fan is spinning a little bit. I'm not sure if it's making cold inside, but it's spinning. At 3 volts I think the fan is not spinning. It's making a strange noise. Somewhere here at 4 volts it starts spinning. Very slowly. Let's not force it to a higher voltage. So that's the output of the transformer, and I'm using some crocodile connectors till this 12 volt connector.